The warmest of greetings to you, and welcome to Happily Ever Teaching. This is the podcast to help you enthrall your learners in every subject under the sun using the best teaching method known to science, storytelling. To do this, we feature special guest educators who are passionately keen for your children to become amazing and successful human beings. I am storyteller Chip Cahoon, and with me today is...
Hi, my name's Rob. I work in Key Stage 2 in a school in Buckinghamshire, and I've taught all the way from Year 3 up to Year 6.
Hi, I'm Helen. I am also a teacher in Buckinghamshire, and I'm currently teaching mixed reception Year 1.
And today we are exploring what maths we can teach with a retelling of Hans Christian Andersen's classic, The Little Mermaid. You can listen to the story by downloading our sister podcast, Fables and Fairy Tales, or search our website, epictales.co.uk, for The Dancing Mermaid. There you'll find a video of me telling the story that you can share with your children. And if you sign up as an Epic Educator, you'll also get a copy as an ebook or paperback illustrated by the magnificent Mario Coelho, as well as the full audiobook for you to download at any time. There are even some tips there for telling the story yourself, and a whole heap of resources to go with the lesson ideas we're about to discuss, including any extra lesson ideas that we don't have time to fit into this podcast. Right now, though, let's continue our discussion with Helen, Rob, and our young mermaid as we explore the maths that we can teach with this story. Who wants to kick us off here? Who found plenty of numbers in the tale?
Well, I've got two things. That's a number.
Got one.
Okay.
I've got one,
okay.
And in total that's 3, so we're going well.
Excellent. There's already some maths involved here.
Early years maths.
Well, let's start with you then, Rob. Ages 7 to 11. What was the first of your two maths things?
The first one I thought of was to do with measurement and to do with measuring capacity. So with volume, it's all to do with the how we measure liquids, and there is quite a lot of the liquid involved in this story. So I would link it to that and say, well, how are we going to measure it? How could we? I would set probably Year 5 or 6 at the upper end of Key Stage 2 a challenge and say, okay, well, how much water is there in the North Sea if this story takes place from Denmark?
How many teaspoons of water are in the North Sea? There you go. That will keep them going for a year, won't it?
Yeah. So that would pull in all kinds of different strands of learning. You'd have to locate where the North Sea is. You'd have to locate which countries are around it. Where do we define the North Sea to and from? Does it go all the way to the top? Does it, on all kinds of things like that? And then different ways that we can measure capacity. Should we use a standard measurement or should we use a non-standard measurement? You could then explore that in class by saying, okay, well, this cup holds 7 pencil sharpener cups full of water, and how can we relate that to a measure that people in other countries can use, and just explore it all that way.
Yeah, I think the North Sea would hold quite a few of them.
Yeah. Yeah, you'd probably need quite big pencils, wouldn't you?
Certainly there's going to be a science discussion involved there as to how you actually learn the depth of the North Sea.
Woohoo! Cross-curricular learning with maths. And then you can bring in, do we convert between litres and millilitres? What would it be if we found out that it held 37 litres? I know it doesn't, just disclaimer, but if it only held 37 litres, how would we write that in millilitres? Is there a bigger measure than a litre? Would be an interesting point of discussion. For example, we have kilograms and grams, and we have litres and millilitres. Is there such thing as a kilolitre?
There must be, surely.
Oh, I want to know now.
So, wouldn't you?
Yeah, I don't know either.
Litres.
Surely there must be.
I'm going to find out.
Okay, do it. Part of Year 5, Year 6 curriculum is using metric and the imperial measurement scales. So then converting between the two of those as well for liquid. It would tie in so much learning. It would make me very happy.
And it could sort of tie in with some of the things we've discussed earlier in this week, because you could think, well, we use milliliters or gallons even, and pints and so on, but they might have a completely different system under the sea, which they use, and you can maybe see about converting between, I don't know, a sponge worth or a cockle shell worth, trying to make them a language that they can actually communicate through maths with those under the sea, the mer people.
Can you imagine trying to make a cup of squash under the sea? The dilution rate would be awful, wouldn't it?
I like the idea, just to thinking of shells and things, of turning this into sort of early years investigation. You present children with lots of shells. I think I've got some in my class, actually. You collect them, and just a tray of water, and just explore capacity that way. Which shell holds the most? It would be very open-ended. Very open-ended investigation, not so much with the milliliters and litres. And kiloliters, which they do exist.
They do exist.
A kiloliter is equal to 1,000 litres.
Oh, there you go.
But yeah, I like the idea of having...
Metric system comes through again.
I like the idea of having lots of different shells for the children to play with it in the water tray, and just exploring, which ones hold more, of pouring one from one to the other. Yes.
The other idea I came up with was to do with time. And again, it's a different kind of measurement, and a lot of work goes into converting different ways of measuring time, or capacity, or length and height. I've written in my notes, no, I can't exactly remember why, but measure 6 years.
Oh, is that the length of time that the mermaids...
She was on land for, yes.
Yeah. Again, how could we convert that into hours, days, minutes, but also as how much of a century is it? How much of a decade is it? So with your older children, start looking at the place value, where you could say it's 0.6 of a decade. And then that's obviously the decimal, it's 6/10 of a decade. So you bring in your fractions, decimals and percentages knowledge as well to that. That would probably not be more than one maths lesson, just talking about that, just how can we convert time in different ways.
Yeah. I was talking about this with a student myself for some of the tutoring work that I do just a few days ago. And I think I'm right in saying, and I really hope I am, because, students take what you say as gospel. I think I'm right in saying that time is the only truly universal measurement. Because everywhere, most places in the world have their own sort of currency. We know that length is measured differently, yards and the imperial and the metric system. But pretty much every country in the world uses hours, minutes and seconds. Am I right?
I would think so.
As far as I know. Yep, I don't know any different.
They kind of have to, don't they? Because
we all have to
that's how time zones work and everything. So, that's... I only mentioned it really because you worried me a moment there, Rob, where you were talking about different ways of measuring time. And I was suddenly thinking,
but I guess talking about that, you could bring in history as well. So how was time measured in the past, before clocks and watches were in the way that we know them now? Say sand timers, candle clocks, water clocks, sundials. Would you measure time using the moon, using the lunar cycle? Which parts of the world still use lunar cycles for things? Because they are still used. I think the month of Ramadan is.
Yeah. I think so, yeah.
Decided on the...
Yeah, as is the date of Easter.
Yeah.
Which affects other things like Mother's Day.
I always wondered why the date of Easter changed. Now I've learned something.
And Mother's Day, in the UK, Mother's Day is based on the date of Easter.
Okay.
So I'd also be really interesting to see if you could figure out when and why they first decided to break it up into 24 hours, because I'm pretty sure even with sundials you would have the actual numbers for the 12 portions of daylight. So it'd be really, really interesting to know when abouts that happened.
Yeah. I'm afraid I don't know.
And how it was all worked out, because we take it very much for granted, don't we? Actually, for that system to have come into place, someone must have done a bit of thinking.
And it's so random as well, deciding to divide it into 24 and
24
divide those
bits,
24 into 60 and 60 again. Yeah, very random choices. Maybe set that as a challenge for your classes. How would they better divide up time?
Yeah, make it more into like tens and units, like most things are. Just work a lot easier.
Why do clocks not have all 24 numbers on them?
Yeah, well, analog ones. Yeah.
Mm-hmm. Ooh, lots of learning.
Brilliant.
And a bit of confusion as well, just to throw that in the mix.
Well, let's escape that for now by going back down to ages 4 to 7, where there's never any confusion, is there, Helen?
I spend 6 hours of each day in a state of confusion.
What is the maths that you pulled out from the story for us?
So it was a bit linked to what I was talking about with English in terms of sea creatures, lots of different sea creatures. I thought it would be a nice opportunity.
And the non-chronological reports?
Yes, sort of. I thought it would be nice to do a bit of data handling with the children because they love, if you give children a book of sea creatures, they're fascinated by it. If you do any of these natural world type topics, children love it and they quickly come up with their favourite creature. So I thought they could have a little bit of if you could be one of these under the sea creatures, which one would you be? The mermaid decided she wanted to be human. If you were going underwater, which one would you choose? And then do a little bit of data handling, gather the information, do the tally charts, pictograms, bar charts, and then going into year 2, really the children can sort of answer basic questions about the information. How many children chose to be an octopus? How many more children chose to be a shark than an octopus? All of those data handling questions. Yeah, that was my sort of maths activity, really.
Fantastic. If you presented them with the choice of shark, how many in your class would choose shark as a percentage?
I would.
There you go. Probably most of them actually. Sharks and dolphins, I think. Although turtles, I think, are the best ones. So yeah.
It's thinking about it just before we leave the maths. Is the Fibonacci sequence something that could pop up here? Because isn't that related to some of the undersea creatures with shells? Is that? Am I just making all of this up?
Tell me more.
I was just trying. I'm sure somewhere I saw this kind of spiral that they've had on an underwater creature. I'm trying desperately to think of or remember the name of it.
I don't know, I'm afraid.
Mathematicians have learned to use Fibonacci sequence to describe certain shapes that appear in nature. These shapes are called logarithmic spirals.
Oh,
and
that's good.
Nautilus shells are just one example. You can also see them in spiral galaxies.
Spirals.
And in many plants, such as sunflowers.
Oh, that sounds interesting. A logarithmic spiral, did you say?
Logarithmic spiral.
Logarithmic spiral.
What was the name of the sea creature?
Nautilus.
Yes, that's sort of what I was thinking of.
Sounds like the thoughts are coming together.
Yeah, gradually.
It would be a good investigation for older children, definitely. Just to explore what the sequence is, when it was created, how it works. I remember one child who I taught previously in year 5 on, when was it? It was the 23rd of November. She handed me a post-it note saying Happy Fibonacci Day. In America, obviously, the date is done the other way around, so it's 1-1-2-3. I was like, yes, good thinking. We've not done anything on the Fibonacci sequence. You just handed me this post-it note saying Happy Fibonacci Day. I was like, I like the way your brain works.
Life in Key Stage 2 is very different from Key Stage 1.
That's sadly all we have time for today, folks. We'd love to hear your thoughts on everything we've discussed in this podcast, so please find us on social media using @TeachHappily, or leave us a review using your favourite podcast app. You can also use social media to let us know if there's a subject you are soon to teach that you'd like us to cover. We would love to help. Please also share this podcast with your colleagues and help us start a story-led revolution in classrooms around the world, so children everywhere can learn in a way that's effective, memorable and enjoyable all at the same time. Tomorrow, the young mermaid will help us teach science. But right now, it only remains for us to say cheerio, and we hope to hear your story soon. So,
cheerio! And we hope to hear your story soon.